in the last video, we had seen how our intuitive idea or our intuitive sense tells us that in order to keep something in motion, we need to constantly apply force on it. Or in other words, in order to keep something in motion, we need to constantly either push it or continuously keep on pulling it. And that was the idea that was prevalent in older days. Okay, so that is when Aristotle had so that is the idea that Aristotle had come up with, that you need to constantly apply force on some object in order to keep that object in motion. In this video, we will have a critical view of that idea. So we'll try to think about it in more detail and see, do we really need to apply force at all times to keep something in motion, and is it true that rest is the natural tendency of all objects? So according to that idea, or in those earlier times, people thought that everything wanted to come to rest. But then later scientists raised the question that, well, objects do not have a brain, so they cannot want to do something. So obviously we might want to rest more and work less, but objects cannot think really. Okay, and so they cannot really want to do something, maybe they cannot want to rest. So let us do a simple demonstration and see that is rest actually the natural tendency of all objects, or is the truth something different? So let's have a look at it. So here I have a tub filled with water, and obviously the water is not very clean, but that'll do. And here I have a piece of wood. Okay, so if I put this thing in water, it floats, right? But that's not important. What's important here is that, so if I keep it on one end, watch what happens when so it's right now the piece of wood is completely stationary, but see, if I give it a slight bit of push from this end, it starts moving. And if you notice, the piece of wood keeps on moving with almost the same speed and in the same direction. So it reaches the other end and it stops only when it hits the other end. Okay, so as soon as it hits the other end, it actually hits the other end and starts moving in the other direction. But yeah, as it hits, it loses energy, but yeah, and stops. So again, I'll show you the same thing again. Here I have the piece of wood on one end, and if I give it a slight bit of push, it continues moving in that direction with a constant velocity, almost constant velocity. So that is something different from what we had inferred in the last video. In the last video, or what Aristotle had a thought, or what was the prevalent thought about motion in earlier days. So that thought was that you need force or a push, actually a constant push, to keep things in motion, and rest is the natural tendency of objects. But here, if you see, we only need a push to set the object in motion, after which it keeps on moving. And to stop the object, we again need to apply force. So if I apply force, I can stop the object. But if see, I push it, I apply some force, it moves. I push it from this side and by applying some force, as I'm pushing it, and I stop it. So it moves with a constant velocity if no force is being applied on it. And if I apply some force, it either speeds up. So while we set something in motion, we're actually speeding it up, right? The speed right now is 0. As I apply some force or give it a push, the speed goes to some constant value, some constant non-zero value actually, and it continues moving in that direction with the same velocity. So this is what people like Galileo and Newton came up with. So their idea was that Aristotle was wrong. We do not need a constant push or pull, or in other words, we do not need a constant force being applied to keep things in motion. And rest is not the natural tendency of objects. In fact, what Newton said was that rest or motion, both, so whichever is happening, is the natural tendency of objects. So the natural tendency of objects is to maintain their status actually. So if they are moving, they will keep on moving, and if they are stationary, they'll remain stationary unless some other force is acted. Unless some other force acts on that object. So that is not a very intuitive idea, and it takes some time to digest that. But what Newton meant was, so if the object is at rest, it will stay at rest, okay, until some other force, be it a push or a pull. So I could pull it or I could push it. So when I apply some force, only then it changes its rest position at rest, and it starts moving, and it will continue to move. Obviously here I have the other end of the tub, but if I had a bigger tub, it would continue to move in that direction like this, and until some other forces act on this thing. Now at this point, a very natural question that comes up is that, so this is only this thing where I push it and it keeps on moving in that direction with a constant velocity. This happens only in this specific case, but in general, when we push something, it moves, but as soon as we stop pushing it, it comes to a stop. So for that, let us look at another object. Okay, so if I look at this empty pen stand here, if I place it here and if I push it, it moves, but when I stop pushing it, it stops. So this now counters the idea that objects stay in motion when in motion. So according to Newton, here there is not just one force, which is my force, but there is a second force, which is the force of friction. So what is friction? Well, friction occurs due to irregularities on this and this surface. So because this surface might seem smooth, and even this surface might seem smooth, but actually they are not smooth, and if you look at them under a microscope, we can see that they are irregular. Due to that irregularity, so the irregularities might look like my fingers, so they are projections outward projections, and those irregularities actually lock into each other and cause a resistance to motion. So it is friction that brings this empty pen holder to a stop. So friction opposes the motion, and while I'm applying this force, what I'm actually doing is I have to overcome the force of friction. So the force of friction is acting in that direction, opposing the motion, and I have to overcome this force of friction. And so in order to overcome that force of friction, I have to apply some force. So that is the general reason why everything around, so because friction is such a universal thing, at least on our planet Earth, that almost everything seems to come at rest. But if you think deeply, if you look at all the forces that are acting on the object, which in most cases which is friction, we see that friction is what stops these objects. And as said by Newton, objects will tend to move in that direction. So the objects when in motion will tend to stay in motion unless they're acted by some other force. In this case, that other force is friction. So it would have stayed in motion, but in this case, frictional force is acting on this, and so that is what stops this pen holder, just like this. Whereas in the other case, this case, we have water, and water water and this piece of wood, they have very less friction. Actually water presents very low resistance to motion actually, and therefore that resistance due to this water, so the frictional force between water and this piece of wood is almost negligible, and due to that, when this piece is in motion, it will continue to remain in motion because there is no other force that is acting on this thing, and because the force of friction in this case is negligible, and you know the resistance due to water is very, very, very low, as low as we can just neglect it. And this can be again seen in case of ships or boats. So it requires very low amount of force to push a ship. So obviously when a ship is at rest, you need some force to actually get the ship into motion. But once the ship gains some speed, it will continue to move at that speed, and a very little amount of force is required to overcome the very low resistance of water. But otherwise this has a very low resistance, and that's how we can very clearly see that objects when in motion stay in motion, and objects when at rest stay at rest, unless or until any other force is acted so if any other force acts on them. Now in the next videos, in the next module actually, we will look into this property of motion and force, so this relation between force and motion in a bit more detail. And yeah, so for this video I just wanted to clarify why the notion that force is required to keep something in motion is wrong.